119 when we are done. So we talked about standard unit vectors on Friday. We also can just have a unit vector, meaning the magnitude is 1, and it doesn't necessarily have to be vertical or horizontal like I and J are. But so I and J are our standard unit vectors like we talked about on Friday. U is just a random unit vector, okay? But so if U is a unit vector and the terminal point of U lies on, what would this circle be called if U is 1? A unit circle. Okay, so if it's a unit vector, the terminal point in standard position, the terminal point lies on the unit circle. Therefore, vector U in component form is AB, can be written as vector U. So if this is the unit circle, this is an ordered pair on the unit circle, then this is also cosine theta, sine theta. All of this is totally related to each other. Or as a linear combination, this would be vector U is equal to cosine theta I hat plus sine theta j hat. Okay. We're good? All right, so every unit vector, every vector is the product, which means we're multiplying, of the magnitude and its corresponding unit vector. We can write this as, so this is vector V, this is the magnitude of V times the unit vector. So magnitude of V times cosine theta, sine theta. And then if that's our scalar multiple, we can actually multiply it in. Then this would be the magnitude of V times the cosine of theta, magnitude of V times sine theta. Then as a linear combination, vector V would be magnitude of V times cosine theta I hat plus magnitude of V times sine theta j hat. All right, so this says to find the component form. Component form is your pointy bracket form of each vector with the given magnitude and direction angle. Okay, so we're going to use this right here. So this will give me, so vector V would be the magnitude, which is 8, times the cosine of 60, and then 8 times the sine of 60. All right, so we write that down because we still have to write down what we're doing. Then we can actually calculate this. What is 60 degrees in radians? Pi thirds. What's the cosine of pi thirds? 1/2. So 8 times 1/2 is 4. The sine of pi thirds is square root of 3 over 2, multiply that by 8, and that'll give you 4 square roots of 3. If you want to check to make sure that your calculator is in degrees, type in 8 sine of 60, and you should get 4 square roots of 3. Not every calculator is going to give it to you nice and pretty in that square root form, but these will. That's one beautiful thing about these. And then we know that it's correct. Okay, we good on all that? So there are some that you should totally be able to do without the calculator. Just be able to reason through. If the angle is not in the first quadrant and it's in degrees, are we capable of figuring out the radians? Yes. Am I going to expect you to just be able to spit it out like you should 60? No. Okay, that's fine. You can figure it out, but we'll use the calculator for most of the rest of this. All right, so that means here on number 2, we're going to find vector A. That is the magnitude, which is 30, times the cosine of 340. And then 30 times the sine of 340. So even though you're going to use the calculator, you still have to write this part down. Then you can use the calculator. And you will get a decimal. If you're not told otherwise, how many decimal places do you use? 3. Okay, so go ahead and find your answer here. So what we wrote the first time, that is the trig form. And then after we actually calculate that stuff, it's in component form. Both of them have the pointy brackets. So, I mean, technically, this is a form of component form. But if you were asked for the trig form, it literally has the trig words in it. It's not just that you use trig to find it. Okay. So trig form, component form. Okay. Any questions about that? We're all good? Okay. So now we're asked to write each vector in trigonometric form. So in trigonometric form, you need the magnitude and you need theta. So remember that I have my vector, and that makes this A and this B. The magnitude is the length of it. So that just came from the Pythagorean theorem, right? And then the theta, that's just going to be your tangent inverse again. It's the same thing we've been doing over and over again in different, whether we're talking about the unit circle or we're talking about polar form or we're doing vectors. It's all the same stuff, all ties back to the unit circle. So I need to find the magnitude in theta in order to write it in trig form. So the magnitude of m is just the square root of a squared plus b squared. So that's negative 3 square root of 2 squared plus the square root of 6. I'm sorry, negative square root of 6. Negative square root of 6 squared. Now, when you square it, do the negatives matter? No. But when you write it, they do, because this is what you are doing, and you are showing your process, and it has to match what you're actually doing. The parentheses, do they matter? 100% they do. You don't use those correctly, it's not going to give you the right answer. So you type that in and make sure that you can get the correct magnitude, which is 2 square root of 6. So make sure that that's what you actually get. Any questions about that? We good? All right, so then I also need theta. Theta is the tangent inverse of negative square root of 6 over negative 3 square roots of 2. Now the negatives cancel out, but whether they did or didn't, it doesn't matter because you're only going to put the positive in the calculator, and that's going to give you alpha. But then we need to know what quadrant do we expect theta to actually be in? The third, because it's negative, negative, right? So I'm going to put a 3 over here so I make sure that I remember I'm in the third quadrant. So once I type that in, I shouldn't even really need to type it in, right? Because it would give me, kind of figure out what it is. But you should get 30. We want it to be in the third quadrant, which is right here. What do you do with alpha to get a third quadrant angle? 180, yeah, plus pi, which is 180 in this case. So 180 plus alpha, which is going to give you 210 degrees. So then, vector M is 2 square roots of 6 times the cosine of 210 degrees, and 2 square root of 6 times the sine of 210 degrees. We were asked for trigonometric form. That is trigonometric form. You don't need to type it in your calculator. If you do, guess what you should get? This, because that's where it just came from, but then you're just going in a vicious circle. So we stop right here because trig form literally has the trig in it. And for those of you in AP Physics, this is your mg cosine theta, mg sine theta. It's the same thing. Okay? What questions you got? Anything? You good? Okay. So let's look at number 4. Number 4, it's given to me in linear combination form. What would the component form of this vector be? It's super easy. Don't make it too hard. Negative 2, 2. That's all it is. Right? It's super easy. Remember, it's well. All right. So we need the magnitude of vector r. That's going to be the square root of negative 2 squared plus 2 squared. So that's 4 plus 4 is the square root of 8. So the magnitude of r is 2 square roots of 2. It's faster to not even use a calculator. Of course, you have to know how to do that stuff that some of you still avoid. But then theta, that is the tangent inverse of 2 over negative 2. So for alpha, I really just want the tangent inverse of 1. You can give it to me in radians. What's the angle that gives me a tangent value of 1? Pi fourths. And then pi fourths in degrees is 45 degrees. Okay. So that's alpha. We want theta. What quadrant are we looking for? Second. And what do we do with alpha to get a second quadrant angle? Subtract it from 180. Okay, so 180 minus 40 is 140. I subtract another 5, and I get 135. Which means that my vector r in trigonometric form is 2 square roots of 2 times the cosine of 135 and 2 square roots of 2 times the sine of 135. And you're done. What questions do you have? We good? Okay, so this last one has disappeared on me, so we're going to have to write it up here. So on number 5, we have vector yz with y being at 3, negative 2, and z being at 5, negative 8. So the first thing I think I want is yz in component form. So go ahead and get yz in component form. You get 2, negative 6, right? X minus x, y minus y. All right, so then go ahead and find the magnitude, the theta, and your trig form. I will tell you on this one, on when you get the angle will be a decimal, and that's okay. It wasn't on the last two, so I don't want you to think you're doing something wrong. Just make sure you use the correct number of decimal places. You're fine. So once you're done, check yourself with me. Don't just copy mine down. Make sure you actually get this. Let me know if you have any questions. And this one, what do we do with alpha to get theta? Subtract it from 360. Yes, very good. Any questions at all? Okay.